This is kind of an overview of what rootstocks do. And if you were to ask any tree fruit researcher what the biggest advancement is in tree fruit production, they would probably say rootstocks. So before the discovery of dwarfing rootstocks, we were pretty much growing trees like in this left-hand picture. So really large and takes a long time to establish those trees because these are all trees that evolved in forests. And so they want to typically grow large, outcompete with their neighboring trees in the forest. But if you take that tree out of the forest, it doesn't really need to do that. And so it's really a problem for growers when they have to pick these really large trees and prune them. They're really complicated. They have to use tall ladders. So if you can grow them on these dwarfing rootstocks, that really helps shrink down trees to small spaces, makes them much easier to manage, and increases yield. And so we've kind of moved away on particularly apples from growing trees here on the left to on the right, and we're starting to get into that more with our peaches now. And so what dwarfing rootstocks really do is shrink down the tree, and that all helps with light interception. So there's been a bunch of work done to show that as you increase light interception, you increase yield. So this is a review of some apple work that's been done and summarized about 10 different papers and found that there's this real nice relationship with as you increase light interception, you increase yield. And so how dwarfing rootstocks play into that is that when you have a smaller tree, you have a more uniform light distribution throughout that tree. So on a whole tree basis, you're actually capturing more light. Where if you were a big tree, you might be capturing a lot of light on the outside of that tree, but you have a ton of shading that's happening in the middle. So that's kind of the physiology around it. This is another graph that just basically says that same thing. So the last one was on whole trees. This is at kind of the spur level. So right where fruit's being produced. And so if you, once again, increase light, getting to each of those spurs that are feeding the fruit, then you're going to increase your yields. So those are all basics that we found and why we've made the switch from growing these really large trees spread out to shrinking trees down and growing them in these tight canopies. So as I said, most of this work has been done in apples. So this is from a nursery called Sierra Gold, and I just looked up what rootstocks they have. So this is list of apple rootstocks. These are more apple rootstocks. And so you'll see that there's a ton of different apple ones because this work has been done happening for a long time. So you can see there's some really productive breeding programs. The Geneva ones are all out of New York at the USDA in Geneva. Bud is Budigovsky, which is from Russia. And there's also some from England at the Malling Research Center. But when we look to peaches, there's a lot fewer options. So we're just kind of getting into more of these and developing peach options. So they only listed three on their website. So it's just kind of show you we're still at the beginning stages of this in developing dwarfing rootstocks for peaches. And particularly peaches, we have some more benefits with rootstocks to help against those soil-borne pathogens that May was talking about. And I'll talk a little bit about that as well. So this is some previous work that Dr. Black had done where they evaluated different peach rootstocks in two sites. One is at our Kaysville Research Station, which is a lower pH site, and then down in Payson, which is in southern Utah County, more of it in our heavy fruit production area. And they have more of those high pH soils in that location. And so peaches are pretty cool that they can grow different species as their rootstocks. And so you can have in this top section, in this peach colored, those are all selections that are just peach in their genetics. And then there are some that are hybrids with other prunus species. So this green section, those are hybrids with peach and almond or peach and plum. And then kind of the same thing for this yellow section down below, which is different almonds and plum hybrids. So this is kind of the summary that they found between those two sites. So I talked about tree size being one of our main things. So you'll see on the y-axis is where a tree would fall at our kind of normal site, which is less stressful at Kaysville. So some of our bigger ones are Level and Guardian, which are kind of our standard rootstocks. And so those came in around 200 centimeters squared of trunk cross-sectional area. And then as you go further down on the y-axis, you have more dwarfing. And so one of the most dwarfing ones was crimps. And then this x-axis makes it a little complicated, but it's a really nice relationship that you see here. So that's comparing how big the tree was at that alkaline site in Payson. So if you're further along the x-axis, to the left along the x-axis, you're smaller relatively at the Payson site compared to the Kaysville site. So that would mean that you're less tolerant to those high pH soils. So some of our worst performing ones were those ones that were just peach genetics. So that's our level guardian. They're in those solid black dots. The gray dots are some hybrids, and then the clear dots are non-peach in their parentage. And you can see those ones performed a little bit better on those alkaline sites going to the right. So that was all done in the past, and then we've kind of had a next wave of plantings. This was all summarized in this really nice fact sheet that Dr. Black wrote and is available. And I would point you all to if you want to read more about different peach selections and genetics that are available. And this is kind of the current wave of research that's happening. So Dr. Black and I are both a part of this regional rootstock research group that does these coordinated trials. It's called the NC 140 group. And so we do the same plantings um, of different rootstock evaluations all across the country. So this is one that I inherited from Dr. Black, and it's on Cresthaven, and it's the NC 140 peach trial that was planted in 2017. So they were looking at 8 different rootstocks, and we had 2 that are kind of our standard controls. That would be Guardian and Level. Level's probably our most planted rootstock in commercial production here in Utah. And then we had 3 in the controller series, one that's out of Southeast called MP29, and then 2 in the Root Pack series. And so I'm going to be presenting data on that. And so it was planted in 2017. And so we are in the ninth, going into the 10th year. We usually run these studies for about 10 years. So this study's kind of reached the end of its life. We kind of know how these trees are going to perform. And so we're going to first talk about survivability, trunk size, yields, and then fruit size, just to kind of show you what these trees are doing. And so these were all grown on a perpendicular V. So it's 2 main scaffolds on that canopy, and it's going perpendicular to the row. And it's kind of a more high density system than what we're used to. Typically in Utah here, we're growing what's called a quad V. So that would be 4 main scaffolds. With that perpendicular V with 2, you can put trees a little bit closer together. And so that's what we're kind of studying with these more dwarfing rootstocks. So this is tree size this past year, so going into year 10. And this is kind of ordered as you go from top to bottom, top being the most dwarfing, and then the most vigorous is on the bottom. So our most vigorous was Guardian, which is coming around right around 100 centimeters squared trunk cross-sectional area. Level just behind that, not very dwarfing. And then you kind of can group Root Pack 20, Controller 7, and Controller 8 as being right about 80% of Guardian. And then you have another step down where you have Root Pack 40 and Controller 6, right around 70% of Guardian. And then one that is quite struggling at our site is MP29. So that was developed in Southeast, and it was really targeted to be against some root pathogens that they have down there, but is not quite doing well here. So it's less than 50% of the size of Guardian. So it might look really good in like a home site, but out in the orchard here in our climate, it looks pretty sad. So but then this is going to be survivability, and this is once again ordered based on rootstock size. So most things are surviving pretty well. We've had very minimal death in some of our standard rootstocks, as well as the most of the controller series, the 8 and 7 and then root pack 20, pretty high survivability. But then we start to see a real drop off once you get to those really dwarfing rootstocks. So controller 6, root pack 40 really struggled to live, and then MP29 also did. And then this is yield. So this is the past 2 years. So kind of as these trees have matured, this should be pretty consistent yield. And what we've had to do with the study is to set them all to the same crop load. So based on trunk cross-sectional area, we would put 1.5 fruit per unit. So if a tree had 100 centimeters squared trunk cross-sectional area, it should have 150 fruit on that tree. And then we would kind of scale it based down. So Guardian would technically have the most, should have the most fruit on the tree. And then it would kind of go down from there. But you can see in both years, 2024 is this darker color here, and then the lighter color is 2025. We don't have a ton of differences other than related to tree size. So those biggest trees had the most fruit, as you would expect. And then kind of that middle range, root pack 20, controller 7, and controller 8, pretty similar yields. And then step down again with controller 6 and root pack 40 and MP29. But this flips a little bit when you look at fruit size. So this is fruit weight here on the x-axis, and then all of our rootstocks. So it kind of flips where you have some bigger fruit on these more dwarfing rootstocks. And that's pretty common that we see. We've seen that in apple too. With dwarfing rootstock research, they put a little bit more carbohydrates towards fruit production than vegetative growth. And so that's what we start to see. And then there's also kind of that crop load effect if you have less fruit, but some of these might have the same kind of tree volume size. So since everything's based off a cross-sectional area, if you had more fruit in that Guardian, that might be increasing the competition compared to like a controller 6 or so that has that slightly bigger fruit size. So that's kind of the update on where we're at now. And then kind of going forward, if you're interested in these rootstocks and thinking about planting something other than level or guardian, those standards things, I would just kind of try to think of these kind of four main types. So first is desired tree size. If you want to be growing trees in really small, tight canopies, maybe look towards those more dwarfing rootstocks. And then if you know your site that has high pH, you saw some of those as you move away from pure peach parentage in the rootstock. They actually performed a little bit better on those alkaline sites, so that might be an option. For those sites that typically struggle with vigor, and so if you know you have a site that has poor vigor, you might try to match it with a more vigorous rootstock, and kind of vice versa. If you know you have a site that has really high vigor, you could probably use a more dwarfing rootstock on it and kind of get the same tree size in the end. And then training system. So we generally see with basically any tree fruit species, the more leaders that you have, that spreads the vigor. And so, like I said, we're typically growing our trees here in this picture with 4 leaders. So a tree that would only have 1 leader would look a lot more vigorous on the same rootstock compared to that 4 liter tree. And then even more if you go down to the southeast where they're doing these real open center systems with 6 to 8 liters, that once again really spreads the vigor and why you can kind of get away with these more vigorous rootstocks. And so that's really one consideration to make. And then the last one is replant disease. So May had talked about this a little bit in her presentation and talked about how you can amend the soil to try to get around these problems. But if you don't have time to try to reacclimate your soil and get those pathogens out of there, switching your genetics is one route. So I'll go back to this table that Brent had put together. And what they're saying is if you switch your genetics, you can kind of get around that replant issue. So, for example, in Grand Junction, Colorado, where they grow a lot of peaches, which is kind of famous Palisade peach area, they had started on level and started to see that as they replanted those same sites onto level again, those trees would struggle. So they're currently, most of their orchards are in Crimps 86, I believe. And then as those have aged, they're starting to see that when they replant Crimps 86 again, that those sites are struggling. So they're thinking of switching genetics again. So there's kind of a progression that you could do of if you know you have a site that has a lot of long history of peach production, or if you're doing this for a long period of time and thinking ahead, you know that if you started on a peach seedling, switch to something that has peach hybrid, and then in the third category, something that doesn't have peach parentage in it at all. And so that's really all I have, and I would be happy to take any questions. Thanks.
Sheesh, I was saying couldn't use Zoom, and that's evidence. But thank you, Jimmy, for that. I'm very interested. One question that I had is the availability of some of these rootstocks. What are you seeing in terms of all the ones that you trialed and their availability to the public?
I think they're still quite limited. I know I want to say, and I don't want to speak out of turn, but I'm pretty sure like MP29 is quite hard to propagate. And in the Southeast, it's really coveted because I believe it's armillaria, that it's resistant against. And so all the growers down there want to plant that. But yeah, I would just kind of, kind of as May suggested, talk to nurseries, see what they have. And they have really nice charts on their websites, usually on what the dwarfing levels are, if they're resistant to any pathogens or nematodes or anything. And so that's kind of your way. But yeah, I think we're still just kind of on the front end of starting to get more of them. So I think right now, probably, I know Crypts 86, I think is pretty widely available. Um, but I'm not quite sure where those controller series are living right now
Okay.
with availability.
Yeah. And have you seen in your trialing or research any rootstock scion compatibility issues like cultivar differences within the peaches to those non-peach rootstocks?
That's a good question. I don't think so. So yeah, we typically have just had just one cultivar that all these are on. So
Right.
we're not doing a ton of comparison. But I think they've generally been found to be pretty compatible. What we're starting to move into next is our next wave is really training system by rootstock. And so to see on if you want to grow your trees in more of a planar canopy and spreading the vigor with different leader numbers, what root check should you do? And so that's kind of the next wave of matching things. But I don't think they've seen too much incompatibility with different scion varieties.
Interesting. Very cool. Well, yeah, we appreciate your time, and yeah, your knowledge. We're looking. I'm not seeing anything else. If anyone has questions for Jimmy, we've asked him to stick around for a little bit, so you can go ahead and throw those questions into the Q&A box. But Jimmy, we appreciate your time and your knowledge.
Yeah, thank you very much.